Okay, today we are looking at lesson 4. We're going to continue applying what we know about circumference. Remember, that's the distance around the outside edge of a circle, kind of like the perimeter of other shapes. And we're going to be using that formula, that equation that we talked about in our last lesson, which was based off of proportional relationships. We're going to talk about uh, given the radius or the diameter or the circumference of the circle, we only really need to know one of those numbers, and we can use that equation to find anything else. So let's look at some of the situations that we'll see today. First, we're going, whoops, there we go. First, we're going to be filling in this table, and in the table, we have the radius, diameter, and circumference of 3 different circular objects, a wagon wheel, a propeller, and an orange slice. Now, we're only given one number for each of the 3 objects, and we're going to need to find the rest. So if you remember from our last lesson, we have a proportional relationship between the diameter and the circumference of a circle. We use the equation for proportional relationships to base our formula and our equation off of that. And so to find the circumference of a circle, we would multiply the constant of proportionality times the diameter. And the constant of proportionality is pi. Now, pi is a number, but it's a long, unending number. So using the symbol for pi is the best way to represent it because it includes the whole value. But for most of our calculations, just for practical purposes, we're going to take this long, unending number and we're going to round it to the hundredths place. So we're going to use 3.14 as our rounded version of pi here. Remember, that's going to be our constant of proportionality between the diameter and circumference of all these circles. So if we're going from diameter to circumference, we'll multiply by 3.14. And if we're going the other direction, we'll divide by 3.14, or we could multiply by the reciprocal. Now, the other easy one is that we need to find the radius for our circles. So if we look at a circle, remember the diameter goes from edge to edge of the circle through the center point, and that is the diameter of the circle. The radius only goes from the center to the outside edge. The radius is half of the circle's diameter. If we were to extend it, we would need 2 radiuses to get all the way across the circle or to get what is the diameter. So let's look at that first. If we have a diameter of 3, a distance going all the way across the circle, the radius is only half of that, which would be 1.5 feet. For the airplane propeller, the radius is 24 inches. The diameter is going to be 2 radiuses to get all the way across the circle here, so we need to double it. So here we wanted half or divide by 2. Here we're going to multiply by 2. So we have a constant of proportionality here as well between radius and diameter. So we're going to double the radius to get 48 inches for the diameter. And we can't do the orange slice yet because we need to use our equation and calculate using the circumference. So let's stop there. Let's figure out the circumference of the wagon wheel using our equation here. So to do that, using our equation, we would take 3.14, what we're rounding pi to, times the diameter, which is 3 feet. So multiplying by 3, and that's going to equal a circumference of 9.4. Nothing's going to change my measurement unit here, so it's still going to remain feet. 9.4 feet is the circumference of the wagon wheel. We're going to do the same thing for the airplane propeller, except we're working in inches. So we'll take the diameter of 48 inches times 3.14 and get a circumference of 150.72 inches. Now, each of these was multiplying the diameter times 3.14. Remember, that's our constant of proportionality here. So to go the other direction, I need to divide. 20 divided by 3.14 is 6.3 centimeters. And then to get the radius, which is half of the diameter, I can divide by 2 or multiply by 1/2 and get 3.15 centimeters. So that completes our table. All of our numbers are rounded, not the radius and diameter, I guess, but the circumference has been rounded because we're using a rounded version of pi here, but we're getting a close enough answer to what we really need in our calculations. Now the next part says, a bug was sitting on the tip of this airplane propeller blade when the propeller started to rotate. The bug held on for 5 rotations before flying away. How far did the bug travel before it flew off? So we have a bug sitting here on the tip of the propeller blade. Actually, let's put it here at the end of the diameter here so we can imagine this is the propeller right here. And that bug is going to travel as the propeller rotates, hanging on to just one end of that propeller blade, and it'll rotate 5 times. That means we need 5 circumferences to represent the distance that bug actually traveled. So if the airplane propeller had a circumference of 150 and 72 hundredths, then let's take that circumference. We're getting 5 rotations out of it, 5 full circumferences, so we'll multiply by 5 and then have a total of 753.6 inches. Now that's a really big number for inches. That's really probably too small of a unit to be using here. It would probably be better to give our answer in feet. It doesn't ask us to do that. But if I want to turn an amount of inches into feet, I would divide it by 12 because every group of 12 inches is going to give me another foot. So how many of those groups can I take from this total will tell me the number of feet. If I do that division, it is 62.8 feet, which I think is a much nicer answer, but not necessary. Now let's take a look at the next activity. I really like this activity. There's a lot of good problem solving in it. And it says Kieran bent some wire around a rectangle to make a picture frame. The rectangle is 8 inches by 10 inches. So we have the shorter dimension is going horizontally here. So we have 8 inches by 10 inches. Find the perimeter of the wire picture frame. So the distance around the outside edge, this black line is representing the perimeter of this picture frame here. The blue line is the rectangle that we have labeled here. Okay, so you can see that this rectangle is surrounded by a bunch of partial circles, and most of them are the same. Well, they're all the same circle, it's just a different part of a circle. So I can see that we have half circles for most of the edge surfaces here along the picture frame. Well, 2 half circles, of course, are going to make one whole circle, and I can see that they're across from each other. So that would make 1 half circle, one whole circle, 2 whole circles, 3 whole circles there. And then if I look this way, 1, 2, 3, 4. Combining each half circle on either side makes a full circle. So I have 1, 2, 3, 4, 5, 6, 7 whole circles just by combining the halves. The only other type of circle that I have here is here on the corners. It looks like I almost have a full circle, but it is not complete because this section is missing. Now, if I divide this circle up, I can see that 1/4 of that circle is missing, meaning we have 3/4 of a circle here on the corner. And that's the same for all 4 corners. So I have 4 3/4 of a circle. 4 of those is going to equal 3 full circles if I do that multiplication. Okay? So if I take 3/4 times 4 to represent my 4 corners, I'm going to have another 3 whole circles. So that brings my total of 10 whole complete circles. 10 whole complete circles are representing the wire around this picture frame. They're just in pieces. That's not important though. So the pieces aren't really a concern. We just need to know the perimeter of the wire picture frame. So if I take a half here and a half here and combine it, that's fine as long as I represent every shape going around the outside edge. Now what I need to know is if I have 10 complete circles, what is the circumference of that circle? Because that's going to tell me how much wire it would take or how much distance there is around the edge of that circle. So let's find the circumference. Now, I don't know anything about this circle. I don't know what the radius of the circle is. I don't know the diameter, and I definitely don't know the circumference. That's what we're trying to find here. So I need to find that about these circles. Now, this shape is 10 inches along the rectangle here. And that makes up 1 diameter for this circle, 2, 3, 4, and then I have a radius and a radius of a circle. Can you see that? So I have a diameter for these 4 circles. I have a radius, and 2 radius make a diameter. So really, I have the 4 diameters and a 5th diameter when I combine those 2 radiuses. So 5 of the same diameter for these circles makes up a side length that's 10 inches long. Well, 10 divided by 5 is 2. So that tells me the diameter of this circle is 2 inches. Let's check that. So if I have a diameter that's 2, 2, 2, and 2, that's 2, 4, 6, 8. We're up to 8. If the diameter is 2, then the radius should be 1. So 1 and 1. Now all of this combined has to equal 10 inches because that was the dimension of the rectangle, and it does. So that checks out. So the diameter of our circle is 2. That means the radius is 1. And now if we need to calculate the circumference, I am going to multiply 3.14, my rounded version of pi, by the diameter of the circle, which is 2. That means that my circumference is 6.28 inches. All right, now it seems like I should be done, but I'm not. Remember, we are finding the perimeter of the wire picture frame. So that was all of these partial circles going around. Remember, we got a total of 10 of those complete circles. So really, I need 10 of these circumferences. That's easy math because that's just moving decimal places and place values around. So getting 10 times greater here is going to make 6.28 into 62.8 inches total. Now that would be the perimeter of the wire picture frame. Next it says, if the wire picture frame were stretched out to make one complete circle. So this was detached from the rectangle, straightened out, and put into one giant circle. What would its radius be? And I'm going to underline radius so I don't forget and write a diameter by mistake. Okay, so we know the circumference of the circle is 62.8 inches. And we have an equation here. So if the circumference is 3.14 times diameter, and I fill in my circumference as 62.8 inches, in order to get the diameter of my circle, I'm working backwards in my proportional relationship, so I'm just going to divide the circumference by my constant of proportionality. 62.8 divided by 3.14 gives me a diameter of, let's see here, 20 inches. So if this picture frame was stretched into one big circle, the diameter of it would be 20 inches. But remember, we were asked for radius. Since the radius is half of the diameter, I just need to divide this by 2. So my radius will equal 10 inches. All right, let's look at the last activity here on the page. It says circle A has a diameter of 9 centimeters. Circle B has a radius of 5 centimeters. Draw the two circles. Which circle has the larger circumference? All right, so the first one has a diameter of 9 centimeters, and that was circle A. Circle B has a radius of 5 centimeters. Now remember, a radius is half the diameter, so really we're talking about a diameter of 10 centimeters. So right away I know circle B is going to be a little bit larger with a diameter of 10 centimeters or a radius of 5. All right, so being that circle B has a larger diameter, its circumference is also going to have to be larger just based on our proportional relationship. The larger the diameter, the larger the circle's circumference is going to be. So now we need to know exactly, or actually it says about how many centimeters larger is it? We're going to have to find the circumference of our two circles using our formula, or our equation. Remember, that's circumference equals pi, or 3.14, times the diameter. So let's do some calculating. For circle A, if we take 3.14 times 9, which is the diameter of circle A, then we would get a circumference of 28 and 26 hundredths. That'd be centimeters still, and that's the circumference there. For circle B, we take 3.14 times a different diameter of 10 centimeters. Easy math here. 3.14 is going to be 31.4 centimeters. So to tell the difference about how many centimeters larger is circle B, we need to subtract. If we take the larger circumference and subtract the smaller circumference, we'll know how much larger it is. And that is, let me do that real quick. 31.4 minus 28.26. It is 3.14 centimeters different. Okay? All right. So if we write that answer, and that's an interesting answer. That's what we round pi to in our calculation. So think about what that meant. We extended our diameter by 1 centimeter, and we gained an extra 3.14 centimeters in our circumference. That's because it's a proportional relationship. Every centimeter or any kind of measurement that we gain in diameter is going to increase the circumference by 3.14. So that means if we were to get a diameter that's 1 centimeter smaller and is 8 centimeters, then our circumference is going to be 3.14 centimeters less than it was here. Each of those centimeters changes the circumference by our constant of proportionality. Okay, the back of your sheet has different questions using the circumference of circles. Please pay close attention to that vocabulary. If it's telling you about radius or diameter or circumference, make sure you know which one you're using and how you're using that equation for circumference to solve for what's missing. I will be posting the answers here in the notes, but please try it first and then check your work using those notes. Have a great day.